pulled up some background slides just for people who joined a little later. But hopefully by now you've gathered that we're using Slicer and ROS in a module that we call SlicerROS2, which basically bridges the two of them. Our primary goal when we started developing this was to enable visualization of robots in Slicer. We can support all kinds of ROS-supported robots, and then to basically communicate with the world through publishers and subscribers. So our approach for doing that, just at a high level, is basically to treat 3D Slicer like a ROS node. So if you're familiar with ROS has a scene graph. There's different nodes that kind of package mechanisms and they communicate with each other through publishers, subscribers, and topics. And in Slicer, there's something called the MRML scene, which you've already interacted with today, where we have MRML nodes. So that's how Slicer stores data, medical images, all of that. So the high level of what SlicerROS2 really is a packaging that does this. So on the ROS side, it treats 3D Slicer like it's a node in the scene graph, and on the Slicer side, it treats ROS like it's a MRML node. So our initial kind of stab at that was just to take the most important communication mechanisms in ROS and port them into Slicer. It was the first version that we released a few years ago. So we primarily enabled nodes in Slicer, publishers, subscribers, parameters, the TF2, which is how ROS maintains their transforms. We ported that into how Slicer does it, and then visualization with this thing we call a robot node, which is basically just a package of all the different models and links and transformations between them. And I guess for those of you who just joined, we saw a lot of this morning, but the primary kind of application is that you can load and visualize any ROS-supported robot. So you're seeing the catheter today. I'll show you a UR later. But if you have a robot state publisher for your robot, you can use the module. Previously, we only supported STL files, so you had to do an annoying conversion. But now we support DAE, so you should be able to just load your robot in no problem. And I think we've seen some utilities of that already, but we had questions of when the Slicer viewer is relevant. Here's a good example. We have a CT of this anatomy that we registered to the robot, and we're planning our cut based on that CT. And then you have a live view that you can monitor, so you can picture having the surgeon in the loop on these kind of things. It would be useful. In Slicer, there's a lot of navigation systems that are kind of already built on top of it. This is an example of one where we use electromagnetic navigation for breast tracking. So here, there's a little EM sensor in this retractor. The entire navigation system is built on Slicer, so we really quickly were able to add a robot in the loop to follow that retractor based on that tracking data, and Slicer is the common middle ground here. And then in Slicer, we have a really active development community. So I know a lot of people have been kind of talking about simulation and that stuff. So this is an example of someone who's ported SOFA simulator into Slicer. And then because ROS is also ported into Slicer, you can have robots interact with these soft tissue organs. And then Junichi showed this morning, but if you have a custom robot, you can really nicely have a custom visual interface for the surgeon to look at, where they can plan their target and then kind of go from there. So this was all things that were enabled a few years ago. Since then, just have to switch to another PowerPoint. Give me 1 second. There we go. So since then, we've been trying to extend it now to have more kind of out-of-the-box tools directly available in SlicerROS. And the first one that kind of came to mind was motion planning. So that's what we're going to be trying out today. You don't need any of the setup from the previous hands-on. So if you're just joining, you should be able to start following along in the container now. And I want to start by giving a shout out to these two people. Kaito is a master's student at Queens. He developed the motion planning module that we'll be using today, and Anton is kind of the maintainer of SlicerROS and was one of the core developers. And so the two of them have been working hard to get this working. So as I said, we had this basic functionality before. Now we added motion planning to that. So you may be already familiar with MoveIt if you worked with ROS at all. It's a standard package that does stuff like planning. You could swap out the planner that you want to do. The really nice parts of MoveIt are that you can visualize this goal state robot, which is basically where you want to go. You can, control each joint with sliders. You can play with different planning algorithms and do all of that. But this is the viewer for MoveIt. I find it pretty hard to work with. So you can imagine that getting a surgeon to look at this might be difficult. One thing it also doesn't have, which we noticed while we were developing this, is a slider to go through the trajectory and stop at individual time points. So yeah, when you're going to medical images, it's not the best tool. So we developed this ROS2 motion control module on top of that, and the idea is that you can offer all of those same tools of visualizing your goal state robot, planning your trajectories, and you can do it relative to patient imaging. So this is something you could actually give a surgeon to interact with if they wanted to plan a trajectory. If you had something autonomous, you could also show the trajectory before they execute it, be like supervised autonomy. But that's what we're going to be working on today. So that's like the kind of SparkNote introduction. I'll start with just kind of going over roughly the basic features that you'll play with today, and then we'll see how far we can get in the last bit of the workshop. But it's a pretty simple module. We have like 3 kind of tabs that we use. We just kind of ported the basic features of Move It into here. And then the idea is we can like add collision planning on top of that, or depending on your application, you can kind of customize it. So the first one is this joint control tab where we have like joint sliders. One nice thing is we use degrees instead of radians unlike RViz, so it's a little bit more intuitive. The 3D control tab looks very similar to what RViz would give you in Move It already, but you have this draggable marker that pops up at the end effector of the robot, so you can move it in 3 space. And then we have this trajectory planning, which is very similar to what you see in Move It, although we added that little trajectory scrubber, so you can go through the actual planned trajectory. So if you want to go into the container, we can start with the actual follow-along session. And the first thing you're going to do is just like launch a clean console. You might want to like close whatever you have open now, and then just launch a console tab. I'm going to try to do this.
By the way, I ran the ROS node list, and I found a bunch of nodes.
Oh, really?
There's some interruption.
Interesting. I wonder if it's like the overlap of the Docker container or something. I don't know.
It might be, if you are in the same data center, it might be on the same local network.
Oh, interesting. Okay.
I don't know. I mean, it shouldn't happen, but I mean,
Should I?
So if you see that kind of symptom, like maybe you run ROS2 node list, and then you see like a list of nodes, and I saw like multiple slicers, like and even after I killed my slicer, so maybe there's some. I don't know if there's a way to sort of contain things within like one machine.
Yeah, I mean that's like a very unexpected symptom of this fast AI thing. I mean, we used to have people install Docker in these things, and then half the tutorial was people trying to launch Docker. So I think this is faster, but there's some growing pains. Okay, so the first thing you're going to launch, I'll leave this up for a second, and then I'll do it on mine. Also, if you open up the web page, you should see this command. We're in the motion planning part of the tutorial now, but you're going to basically open a terminal and launch this control. Or launch this terminal, sorry, this command. And when it works, you should see like a bunch of lines spit out, but nothing should pop open. Your terminal should just populate. That open for a bit. You should have it on the tab too, or on the website if you're working there. And I'm going to launch it on mine as well. Here, okay, so we're going to source.
So there seems to be an environment variable to limit that. Like I think it's called the.
Oh, is it not working?
It's called like a ROS domain ID. I don't think this is for ROS. Yeah.
Are you running into? Are you on the instructor one also? Or?
Oh yeah. I mean, I'll probably.
Maybe you can just. I can show as you do it. I can close mine and then launch yours.
Oh.
I opened the instructor one as well, so that is okay. I can do it.
Oh no, you can use that. Which one are you using?
I opened the instructor one.
Oh, okay, that's good.
But if you already got stuff working, I can just open it.
Well, I closed mine, so you.
Okay.
Yes,
okay.
Yeah.
So it's UR5.
If you have any questions, let me know. I can help. That's good.
Is it working? Sorry, my copy paste doesn't work on mine either. The selfies doesn't really load for me. I have to use the guacamole.
Yeah.
Yeah. Let's just watch our business.
Is anyone using number 11? Are you using 11?
Okay, I think I'm on 11.
11. And then
I'm on 9.
9. Who's 10? Are you 10?
I think I quit out of my session, so I should be on
All right.
Okay. We have one more command to run, so I'll make this full screen. You guys can launch it as well. It's really slow in between the event, but this is in another terminal. You want to just source ROS and then run this one command. And this one should launch like an RViz viewer, so you should see a robot pop up.
Are we supposed to deactivate
No, that's a force of habit of mine, so it doesn't really matter. I find it sometimes adds weird behavior. You can do it or not. But sorry. I've had it before where I was debugging something for like 2 hours and just deactivated con fixed it. So it's like a involuntary thing. Okay, I'm gonna port this over to mine as well. Okay, so hopefully that should have worked for people, and you should see like an RViz viewer with, I'll stop sharing my PowerPoint for a second, or actually I have a slide. But you should see like a movement viewer with the UR pop up, should have an orange thing over top of it. That's your, goal state robot. If you want, you can like kind of interact with it a little bit. This is like your typical move it viewer. So if you drag that 3D button, let me actually share my screen. I need to do the robotic view. Okay, so you should see like the UR pop up. You can like move it around with this little thing. That's your goal state, that's your UR. Is that working for people? Okay, so quickly, you're gonna switch to the context tab. This is, I found, like, if you've used Move It a little bit, these are like the actual planning libraries. I just found OMPL would make the robot do like a crazy trajectory to get to one spot. So if you switch to Chomp for both of these, I think that works better. So you can just do that quickly. Oh, it died on mine. Something's weird with this container. It just crashed.
Oh, the same thing.
Yeah.
Here.
Is it happening to you as well? Everyone's it's dying. I wonder if it is like the no.
Yeah, I mean, so maybe we could try, this is what I found. This is a good test. So there's an environmental variable, like,
Oh, okay.
and then that will kind of limit the communication within the local host, like ROS domain ID. So it has to be unique ID.
Do I just do like set ROS domain ID or?
Oh, export, I think it's.
Export,
Yeah, it's like a ROS.
ID.
Oh, you kept that. Okay, good. And then like equals.
Mhm.
I don't know. Maybe you could like 0.
0. Is it like colon equals or just equals?
Just equal.
Okay, 0. So you think that we're all on like the same?
I mean, some of them because we kind of try to. Some of them are Maryland. Some of them are like the Texas.
Oh,
So like
That makes
they might be
sense.
in the same say the same place.
Leonard wants, like, third Dr. Leonard said that if you have this issue, if you put this, it'll prevent crosstalk in the same network.
That looks like this might be a little better like ROS local host only one. If it doesn't work, maybe you should try this one.
Okay.
Um,
It looks like it's working roughly. I don't know if this is actually.
every time you start, you can
I do have it in my background, but it's what
that's good.
Okay.
ROS underscore.
Yeah, it's not working for me.
Okay.
What is it? Export ROS.
ROS underscore local host only. Yeah, ROS underscore local host. Local host. Yeah, the one word. Yeah.
Only.
Underscore one.
Underscore only.
Yeah.
Okay. Just that?
Yeah, equal.
Oh, sorry.
Equal one.
Equal one.
Yeah.
Okay, I'm gonna run it in this one too. See if that- Okay, hopefully people are seeing this on their system too. Let's try.
So Kelly, did you have the same problem and then solve it by doing that or?
I'm on my personal hotspot, so I don't think
Oh.
I have any crosstalk.
Oh, okay.
Okay, you should be seeing this little robot.
Oh, good.
move
It's
around.
working.
It looks like it's working. Yeah.
Oh, good.
And
So
then-
did you try that one?
Set this
Okay.
to chunk. And it should
Oh, okay.
still work.
If it's working, that's good.
I guess it depends what instance you were on. Like
Yeah, right,
where
right.
it
But I mean,
was.
he had the issue before, so yeah. If it happens again, maybe we try that command.
Okay. Okay, so that should be fine. So in another terminal, you're gonna switch back to the main workspace, source it, so it's ROS2 workspace, install setup.bash. You can source ROS as well. And then we're gonna actually launch Slicer. So you should just be able to like tab for everything, so it's Slicer, ROS2 module, and then Slicer .launch.py, and that will pull up Slicer for you. Is that working? And yeah, these commands are on the website in the motion planning tutorial, so if you're well behind, just pull that up. Okay. Now we're going to switch to the ROS2 module. So if you do Control F, Control F, you should be able to like type ROS2 in, and that will switch you there automatically. Make this full screen, and we're going to do the same thing of adding in a new robot, and then just pressing load robot. And you should see like a UR pop up. Yeah, is it working for people? Okay. And the next thing, I guess you can see, we're on a development branch right now that we're merging into main, but you can see the robot has like more definition than it used to because we added like that DAE support, so you can see all the little links kind of showing up. It's nice for visualization.
What do you click that button?
I'll give everyone a second.
And do you know how the like DAE stuff works with the URDF? Like, do you like so you're not using an STL anymore?
Yeah, you used to have to like modify your URDF to have an STL. We linked it against this package called a SIMP, like ASIMP, which is kind of funny. So now that's built in. So now you can just use your URDF. So if you have like a robot with a robot state publisher and you can see it in RViz, you should be able to see it in Slicer too with no changes.
But like the URDF itself is also using the DAE format?
Yeah, typically they do. Like at least for the UR, for all of them,
Okay.
it's usually DAE or sometimes like OBJSTL. It'll handle the other ones too. It used to just be like you have to go and do some modification, and we'd find that people would like get things working, load the robot, wouldn't see it, had it converted to STL, and then they would stop using the module. So hopefully this gets more people to use it.
Nice.
So people have a robot launched? Okay. So now you're going to, again, Control F, and then switch to ROS2 motion control. This is the new module. So you should see an interface like this. And you can select Use on Robot 1. We only have one in the state, or in the scene. And you should see like a little blue robot kind of shows up in a weird spot, but it should be there. Okay. I wonder if I am getting like crosstalk now. It's showing up in a bit of a weird spot, but we'll go with it. So you should see like some robot appearance stuff populate. You can change the color of like the goal state robot if you want, like from blue to pink if you need to, just visualization tools. And if you switch to joint control, you have access to those sliders. So you can like move the robot around by each link and kind of do that in the scene. So hopefully this is working for everyone. Yeah. You can also do like home. That'll take you to like the UR default home, or current state will take you to where the robot actually is. So if you have this connected to a real robot, which we've tested it on, it will actually listen to where the encoders are saying the robot is, and you can start planning from there, which is probably safest. Next, you have this like 3D control tab. So in here, you can get that same 3D viewer, so you can drag the robot around. So if you don't select Move Group Exists, the default is that it's just using like the built-in inverse kinematics library in KDL. So if you don't have a Move It package for your robot, you could already use this much. But if you do and you want to do actually trajectory planning, you select select Move Group Exists and then type in UR Manipulator. And this is just the name of your planning group. And then use Move Group. And now that inverse kinematics is coming from that planner that you selected in Move It. So you can actually see it's a little bit smoother when you're doing that, but it'll constrain you. Like if I try to bring the robot over here, that's not feasible. I don't know why I'm like off. Let me try to center the robot a bit better. And then once this is enabled, it allows you to click the trajectory tab. So this is where like the fun stuff comes up. So if you do like plan, it'll actually show you that a plan was successful if the trajectory scrubber pops up. You can do preview. So this is why I switched to Chomp, but I guess my motion was a bit weird. That was a trajectory, kind of insane. I think that depends on the planner you plug in.
Can you play it again?
Yeah.
Going on there.
Yeah. So if a patient was there, it would be a bad sign. If you switch and we do like, actually let me execute that. So anyways, you can like scrub through the trajectory at each state. So again, this is like the nice part. You can imagine if you like had an AI generated trajectory for a medical image, you could have the surgeon actually preview what it's going to be, look at each layer that it goes through, and then decide. And then if you press execute, it'll actually follow that motion. So hopefully useful for that. I really think for like surgeon in the loop kind of context, this is a nice tool. Don't know why I've ended up there. Oh, I'm halfway through the trajectory scrubber, that's why. If you click like a closer motion like this, that plan should be a lot less egregious, but let's test it. Yeah, so it's just like shifting over, and you can see that. So how are we doing for time? Okay,
That's good. Like I think 12:30, right?
Yeah, I think we're okay. So the next part, I'm gonna have you kind of add a custom end effector and then a model into the scene. So you just want to open up another tab, and we're going to clone a repository, which is github.com, my name, and then I think think it's slicer underscore, let me just quickly check. Yeah, SlicerROS2 underscore tutorial.kit. So this is just to get some data that we're going to load into the scene. So hopefully that's working for you. You can check quickly by opening like a file explorer, and it should be just in like your home folder. Where did I clone that? What folder am I in? Oops. Oh, I'm in workspace. My bad. I'm actually going to change and do it somewhere else. Okay, so you should see like this folder pop up, and then if you go into data, there's some scenes in here that you can load. These are like pre-saved slicer scenes. So you want to navigate to this spine and e.mrv. So it's a MRV scene that will have a spine model, and then EAE is like an end effector that we customize. So you should be able to, I'll do that again. If you just take the folder and you drag and drop it into Slicer like this, it'll pop up with a window that says, do you want to load it? And you can just press OK. And then you should see some stuff show up. I mean, spine is higher than it should be because our robot is lower than it should be, so we're going to improvise and move it around and try to be useful for you. So to do that, and I guess this is useful in general, you go to the Transform tab. I guess I'll stop quickly. Is everyone like caught up on where we are right now? Yeah? Okay, so if you go to the Transform tab and you select, let me just check if we already have one in this scene. Okay. Transform. Okay, so we already have a transform in the scene. You can just apply the spine to it. So you go to the transform module and you click on transform up here, and then you scroll down to have this, and you can just press this little arrow next to spine, and that will like actually move the spine already into the scene. And then the easiest way I find to interact with these transforms is to go into display and do visibility. You can do check here. Okay, yeah, some things are weird happening, but when you move this around in Slicer now, you should move the spine. Again, don't know why things are lower than they are. Usually this is all in the box. So that's a bit of a weird symptom of this fast AI thing, but that's okay. So you can move it kind of roughly in front of the robot. You want to just be in like the reachable workspace, and then you can rotate it so it's like in a more useful position. So it's a little bit of playing around, but I'm going to move it like this. And then you should have like your spine in front of your robot. You might need to move it a little bit closer. But this is something you would typically like establish with an actual registration of the robot to the patient. So we'll find out if this is like visible later, and you can kill this visibility once you're done moving that around. Yeah? Okay, and then if we switch to the data module, here you're going to switch to the transform hierarchy tab, and we're going to add end effectors to both our gold state robot and our typical robot. Again, this is something you would probably program into your URDF file, but just for the UR example, we don't have one by default. And I actually generated this like STL of a end effector just with Claude. I asked it for an end effector of the UR5, and it gave me something in one prompt. So you should use Claude. But you can like extend the tree. So this first one that we're looking at is the actual robot, and then this one below is like the goal robot. So you want to extend the whole transform tree. And you, as you're doing that, you can like see all the models that sit at each tree. So each of these is like a TF kind of transform. You can see like ROS2, TF2 lookup, and then it says like what it's between. So link to wrist, all of that. You want to go right to the end. And we're going to scroll down and take this UR stylus and drag it onto, I think it's link to flange. And you should see like a spike kind of show up on the robot. And I guess I'll do that dragging and dropping because sometimes that's confusing. So pick up UR stylus, click it and hold, And then if you like drag it onto this link to flange transform, it should like, there's a little box around it, you can let go and it'll show up there. And then you're gonna do the same thing for the goal robot. So extend the whole transform tree, this, and you want to add, in this case, the transform tree is a little bit different, but you want to take this UR stylus goal and add it onto tool 0. And then that's on the, we call it like a ghost robot or your goal state robot, but there's a little end effector there too. So now you have something you can actually like point at stuff. This is pretty common for registration. Like you'll have a pointed stylus that you'll bring to like target points to initialize like ICP or something like that. And so if we go back to the ROS2 motion control, we can now like plan with this end effector. So you'll see it's a little bit hard with the arrow. And if you zoom in, you can see our goal state robot has that pointed end effector as well. So we can actually like drag this onto, you know, a point on our patient model. And you might have to like orient yourself in the 3D views for a bit before you can get this working. Okay, so this is a weird thing. The ghost is shifting off of the actual robot. Now the robot's in the right place. I've never seen that before. So I think that might be like a crosstalk thing. Let me just see what happens when you press plan. Okay. Our robot should be on top of it, but you guys just saw it like glitch there. I don't know.
What if like we run the robot like that?
Yeah, good point. Execute.
Okay, yeah.
Yeah. I mean, I've never seen this when we tested it before. Maybe I can like start with a new robot if I delete. No, I don't want to delete that one. Maybe if I can select this and then use. Okay, I have a new ghost. Now my anatomy's in a different spot, so I'm going to quickly move it back. Doing this again. I mean, we have lots to report back to Kaido in terms of weird behavior. But yeah, so if you go back to 3D control, that's the transform control, so we can hide it quickly. This. And go back to this 3D control. You should be able to like actually drag the robot. Oh. Okay.
Did you say you just made a new robot?
Yeah.
The little RQ balls?
Yeah, it looks like the end effector is gone. That's okay, but the actual I had to like reselect move group exists for this robot, so that should be fine. You kind of get the point. But basically, if you do like this, you can plan a trajectory. Here we'll see the actual stylus on the real robot. Again, crazy trajectory. And then we can execute it. This would kill a patient, I'm sure.
I don't want to be treated by this
yeah.
robot.
And I don't know if it's actually on the robot. The kind of high level, what we wanted to show is if you had like a real registration and then you had points that you could somehow track on your anatomy, now you have like a nice means to actually plan a trajectory based on that, preview it and execute it with whatever planning tool that you're using in Marcus.
Is there a way to like click a point in itself instead of like trying to like get it to like kind of look like you're?
Yeah, I think it would be more like programmatic. Like you could set the position of this end effector pretty easily by grabbing the transform and like setting the X, Y, Z in Python, I would say. So if you had like a list of fiducials, you would take this transform, which is just like all of the TF2 lookups are coded as normal transforms. So you'd basically set that like the X, Y, Z to be whatever that point coordinate is.
But
Yeah.
like if you had like fiducials, like visually you can like
Mhm.
like snap to the center or anything like that.
We don't have that right now, but it's a great idea. In a report back, that shouldn't be too hard to add. Yeah, but basically you're saying like make your inverse kinematics like a point in the scene that's defined by a fiducial.
Yeah.
Yeah, I
I
mean,
guess the orientation could get tough, but I don't know.
yeah, that's when you're dragging, you're moving an entire transform. But I mean, if we could just set the orientation that you're currently in
Yeah.
and do it. It's a good idea for a feature. Yeah, you can definitely add something
I think
like
some in
that.
our lab had like kind of difficulties with that. Or they were like trying to like check registrations, but You're like, oh, we're like, we look like we're close, and it says like 2 millimeters, so it's probably like.
It's not perfect, yeah. Yeah, I mean, the cool part I can show you guys as well, we have this other group that has kind of taken, so we're trying to bake things like directly into SlicerROS as much as possible. This is a group from Toronto. We're doing another workshop with them actually at EMBC if anyone's planning to go. They've taken the module and like customized it for the Franca robot because they use it for classes, and they do stuff like that. So they define trajectories based on anatomy. It's really like SlicerROS2 under the hood. Is the video still playing? I think they have a couple examples, but they'll like take these kind of surfaces that they extract from meshes, from segmentations, or like fiducials like that, and they can get the Franca to actually follow. So I think in our experience, like people will typically take SlicerROS and then build their example application on top of it. But with this motion control, it's kind of our first time trying to be like, how can we add generic tools that are not just loading a robot and publishing and subscribing? So yeah, if you have any like ideas for features, our GitHub is open. You can leave issues and do whatever. So if there's something you would like added and you don't want to program it yourself, please feel free to leave an issue. Or you can contribute as well. We're open to that too. There was a student at UT Austin who needed like point cloud support, so they added it themselves, and now it's a subscriber that we support. So you can do things like that. But yeah, here you can see like they don't have the kind of goal state robot preview. This was built on like a previous version, so we're kind of working with them now to see how we can like merge the two, the trajectory preview and then some of these cool trajectory generators. Yeah, I think that was all that we have for the workshop.
That's good.
We're on
Yeah.
time actually.
Yeah.
So that's
Awesome.
good.